All right, so solving a rational equation. Solving a rational equation, the process is the same as what you would do if you were solving a basic algebra and you wanted to get rid of your fractions. You multiply everything by the common denominator, except this common denominator looks a little bit different. You need to factor all of your denominators, and then you need to figure out what factors you're missing and multiply those guys by it. So like if I were to look at this, I would say, well, this denominator is n minus 5. This denominator is n minus 4. So my common denominator is going to be n minus 5, n minus 4. If I multiply everything by that, I will get rid of all my denominators because I have taken every piece and put them together. So if I take this equation here, and I have 3n over n minus 5, and I multiply it by that common denominator, n minus 5, n minus 4, and equals this guy, 3n plus 1 over n minus 4, and multiply it by n minus 5, n minus 4. I have not changed my equation. I multiply both sides of the equation by the same thing. My rules of equality say if you multiply one side by something and the other side by something, it is still equal. Even though this something is humongous, I multiplied both sides by the same thing. All right? It did not affect my equality. Now that I've done that, I can reduce. Well, what cancels over on this side? Well, the n minus 5 does, which is my goal. The n minus 5 cancels, and I'm left with 3n n minus 4. What cancels on the other side? Well, the n minus 4 cancels, and I'm left with 3n plus 1 n minus 5. Simple enough. I actually have something I can solve now. So, solving's easy. I'm going to distribute. I have 3n squared minus 12n. Over here, I need to FOIL. 3n squared minus 15n plus n minus 5, right? Combine your like terms. Obviously, these guys end up being negative 14n. You do want to move everything to one side. This is a quadratic, right? Anytime you have squares, you want to move everything to one side. You'll notice if you subtract 3n squared from both sides, they were very kind. Those cancel, right? So I have negative 12n equals negative 14n minus 5. Now I'm in a situation where I can just solve for n. I don't even have to worry about a quadratic. My quadratic piece canceled. So add 14n, add 14n. We get 2n equals negative 5. N equals negative 5 halves. Now, one thing you have to think about is this is a rational, meaning I have a variable in my denominator, okay? So you have to check him and say, would he cause a problem? So when you think about these, you need to think about your domains. My domain would exclude two numbers here, right? My domain is going to be all x except for two of them. Positive 5, because that would make this guy 0. And positive 4, because it would make that guy 0. All right? As long as what your answer is not one of those exclusions, it will be a correct answer. If I were, however, to get negative 5 halves and 4 as a possible answer, I would have to exclude 4 and say, no, 4 cannot be an answer. 4 would cause a problem in my original, okay? So when you do these rational solvings, you need to compare your answer to your exclusions. What would be excluded? If it's one of my exclusions, it is not a valid answer. It's extraneous, basically, is what it turns out to be. Just like we had with our radicals. Okay, if the radical caused a problem, it was extraneous. So sometimes it's best to upfront say, what are my excluded ones? So I have that sitting up there, solve it, and just make sure your answer does not fall into one of your excluded values. All right, so let's try one. So for this example, you'll notice my denominators are slightly larger, right? But they did give us 0 on the other side. That's nice. All right. So we want to look at the factors of each one. The factor of this one is x minus 4. The factor of this one is going to be x minus 4, x plus 1. And the factor of this one is just x plus 1. All right? You only have to use them once. The only time you have to use them twice is if one of them has it squared. So like x minus 4 is used once here, once here. I only have to use it once, okay? It's like having, 4 and 8 as your denominators. You wouldn't use 4 times 8 as your denominator. That'd be way too big. You would just use 8, right? So you don't have to use it twice unless this guy was x minus 4, x minus 4. If it were used twice in one denominator, then you would have to use it multiple times. But you only have to use it to the lowest degree that it's been used. So my denominator is going to include x minus 4, which takes care of these guys. And my denominator is going to include x plus 1, which takes care of those. So my common denominator here, my least common denominator, is just x minus 4, x plus 1. All right? So what cancels? Well, if I take this one here and multiply it by my common denominator, the x minus 4 will cancel. So my x plus 2 will be multiplied by just the x plus 1 because I canceled out that piece, right? Minus, what cancels for this one? Well, all of it. This denominator has all the pieces. So the whole denominator will cancel, and I'm going to be left with just that 30 on top. Don't forget it's a minus. And then in the last one, I have that 4. What's going to cancel here? Well, the x plus 1 will cancel, and I will be left with just the x minus 4. What's nice is if I multiply this side by my denominator, I just get 0, because 0 times anything is just 0. So you'll notice that you are ending up multiplying the numerators by the piece of the denominator it did not have, right? That's what you end up doing. And so once again, you're going to do this exactly the same. You're going to FOIL this, x squared plus 2x plus 1x plus 2 times 1 minus your 30. Don't forget you are subtracting here, so distribute your negative 4. Negative 4 times x, negative 4 times negative 4. All right? And then, of course, you want to combine any like terms that you have. They have x squared. He doesn't have anything to combine with. Positive 3 and negative 4 give us just a negative x. All right. And then we have a positive 2, a negative 30, and a positive 16. That is going to be a negative 12. And again, they were nice. This is nicely factorable. So it factors to x minus 4, x plus 3. My two possible answers are 4 and negative 3. But I need to look at my domain. My domain is going to be all x except what makes these 0? 4 makes that 0. 4 makes that 0. Negative 1, negative 1. So all except 4 and negative 1. We have a problem. This cannot be an answer because I said it was not part of the domain. You definitely can't have that. So my only answer here is negative 3. All right. All right, so let's look at this. Find every number whose opposite is equal to the reciprocal of the sum of the number and 3. So first of all, do we know the number? No. So we are going to call it x. So x is our number. All right, so now we're going to base everything, when they say the word number, we're going to use x, right? So the number whose opposite, how do I write the opposite of x? Negative x is equal to, well, that we should know how to write. Reciprocal. Reciprocal means 1 over, right? So 1 over sum, that means addition, right? Of the number, we don't know the number, x, and 3 plus 3. There we go, right? Everybody see how he did that? Just break it down. Now, what do we have? We have a rational, right? What's my common denominator here? Well, my only denominator is x plus 3. So I need to multiply both sides by x plus 3. So I'm going to multiply this side by x plus 3, and I'm going to multiply this side by x plus 3. On the left-hand side, I just have negative x times x plus 3. On the right-hand side, I just have a 1 because these both cancel. Distribute negative x squared minus 3x equals 1. This is a quadratic. So I want everything on one side. I always, always, always have my leading coefficient positive. So I always move it to the other side if it's negative. So I would add both of these actually over to the other side. And of course, I'm going to put that in standard form. So on the left-hand side, I have 0. Here I have x squared plus 3x plus 1. There are no factors of 1 that add up to 3, seeing as how the only factors of 1 are 1 and 1. So the only way to solve this is quadratic formula, right? Or completing the square, again, which nobody ever does. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Just simplify it. Negative 3 plus or minus the square root of 9 minus 4 all over 2. This is going to be an irrational plus or minus the square root of 5 all over 2. That is my answer. The only exclusion I had was negative 3. That is definitely not negative 3, right? So that is not a problem. If they want decimals, just plug it in. If they want exact, that's your answer. Okay? So the word problem is not difficult. Just break it down into algebraic expressions. All right? A tank can be filled by 2 pipes in 2.4 hours. If the large pipe alone takes 2 fewer hours to fill the tank than the small pipe, how long would it take the small pipe to fill the tank? Okay. So they're filling, both of them are filling it. So we have the larger one and the smaller one. They don't tell us how long it takes either one individually, but together they fill it in 2.4 hours. Okay. So we have the work is being done. That one pipe is being done with the large one and with the small one. The rate, it's a unit rate. So one pipe being filled by the large tank and one pipe being filled by the small tank. But if you put those together, it is filled in 2.4 hours. All right. Well, the whole tank, sorry. One tank pipe in 2.4 hours. So one pipe being filled in however long the large one takes it, plus the one pipe being filled in however long the small pipe takes it, equals the one pipe being filled in 2.4 hours. Okay, it's like a unit rate. The problem is we don't know the rate. They relate it back to the small pipe. Do we know how long it takes the small pipe? We're going to call this one small, and we're going to call this guy the large one. We don't know. We don't know the rate, so we're going to put a variable there. We don't know how many hours it takes them. Okay? Do we know the large one? No, but they do relate it. It takes 2 fewer hours than the small guy. So if the small guy is X, how do we say 2 fewer? X minus 2. And then I have this guy. Now I will tell you he's not pretty with the decimals there, but those are my denominators. The large one can fill it in x minus 2 hours. The small one can fill it in x hours, and together they can fill it in 2.4 hours. So I have yet another rational is what I have here. Now, my denominators are ugly, but individually they're already reduced. You can't factor these at all, right? So my denominator is going to include 2.4. My denominator is going to include x, and my denominator is going to include x minus 2. And I am going to multiply everything by that. All right, everything by that. So all the way over here on the left, if I multiply this guy by my denominator, my x minus 2 will cancel, and I will have 1 times 2.4x, right? In the middle here, if I multiply it by this, my x will cancel, and I will be left with just 2.4 times x minus 2. And then all the way on the other side of the equal, if I multiply by that denominator, my 2.4 will cancel, and I will be left with x minus 2. All right? So far, so good. And then I'm just really going to solve. I mean, this doesn't simplify. We just have 2.4x, distribute here, 2.4x minus 4.8. And over here, we have x squared minus 2x. All right. By the way, for those of you who would spend 17 hours trying to factor this, when you have decimals, just use the quadratic formula, okay? We're going to get everything to one side, and then we're going to use the quadratic formula. So we're going to subtract, well, this is going to be, by the way, 4.8x. So we're going to subtract 4.8x minus 4.8x. We're going to add our 4.8, So we have 0 equals x squared minus 6.8x plus 4.8. I promise, just plug it in. Plug it into the quadratic formula, just like we did before. Negative b plus or minus the square root of b squared minus 4ac over 2a. And by the way, just use your calculator. It will do all of it if you do your parentheses correctly. And if you're not comfortable doing your parentheses correctly, do it a step at a time. But in your calculator, it will do order of operations. So you can put 6.8, right? Parentheses there. You're going to have to do it one at a time because it's not going to do plus or minus. You can do the square root and do parentheses and do your negative 6.8 squared. It will do order of operations. Minus 4 times a, which is just 1, 4.8. Close parentheses, close the parentheses again, divided by 2. Like, it'll do it all for you, right? If you know your order of operations and where to put your parentheses. If you don't want to do that, do it a piece at a time. Figure out your square root, do plus and divided, do minus and divided, okay? But when you do this, you're going to get 6 and 0.8, I think is what they get. They get 6 as one of my answers, 0.8 as one of my answers, all right? So it says, substitute into the original equation. 0.8 for the small pipe would cause the time for the large pipe to be negative, right? So here are my two answers. It could be 6 hours or 0.8 hours. Well, if I were to plug these back in, 0.8 works here. But if I plug a 0.8 in here, I have to think about two things. Does it cause a 0? Does it cause negative time, right? 0.8 minus 2 means that the pipe takes negative 1.2 hours for it to fill up. That's not possible, right? It needs some amount of time to fill up. So this is not going to work for mere logic reasons, okay? So there are going to be times when it doesn't work because it doesn't fall in the domain, right? And then for word problems, there are going to be times when it doesn't work because it doesn't make sense, okay? Negative time does not make sense for how long it takes a pipe to fill up. So the only logical answer is that the small pipe takes 6 hours and that the large pipe takes 4 hours, right? That's logic here. And so you're going to go with your logical answer. And you can plug it back in and see if it works. If you added those up, would you get that answer? All right, does that make sense for word problems? So word problems are going to be done exactly the same. You are just going to need to look for domain and reasonable answers, okay?